The Messenger mission of NASA lasted 10 years, 8 months, and 27 days. What did this mission accomplish? To know more, watch this video, where the English is bad, but the science is really good. Messenger was a NASA robotic space probe that orbited the planet Mercury between 2011 and 2015, studying Mercury's chemical composition, geology, and magnetic field. The name is a backronym for Mercury Surface, Space Environment, Geochemistry, and Ranging, and a reference to the messenger god Mercury from Roman mythology. During its stay in Mercury orbit, Messenger's instruments yielded significant data, including a characterization of Mercury's magnetic field and the discovery of water ice at the planet's north pole, which had long been suspected on the basis of Earth-based radar data. Top 10 science results from the mission. 1. Volatile-rich planet. In simple terms, it is a mercurial planet. The planet is surprisingly abundant in volatile elements that evaporate at moderately high temperatures. Particularly high potassium concentrations were observed. Relatively high abundances of other volatile elements, including sulfur, sodium, and chlorine, provide further evidence that Mercury is volatile-rich. The high sulfur contents combined with low amounts of iron on the planet's surface additionally indicate that Mercury formed from materials with less oxygen than those that formed the other planets. 2. Polar deposits. Messenger has provided multiple lines of evidence that Mercury's polar regions host water ice. Shown here is a view looking down on Mercury's north polar region, with 0 degrees longitude on the bottom of the view and extending to 65 degrees north latitude. The first frame shows an identification of the host craters for all of the radar-bright deposits. The second frame shows the topography of the region. Illumination models show that the radar-bright deposits are located in regions of permanent shadow. The third frame shows that the decreased neutron flux at higher latitudes is evidence for the presence of hydrogen, as in water ice, in Mercury's polar region. The fourth frame shows a map of Mercury's maximum surface temperature. The temperatures range from 50 Kelvin indicated by purple color to greater than 550 Kelvin indicated by red color. The permanently shadowed craters near Mercury's north pole have thermal environments that allow water ice to be stable in these craters either at the surface or a few tens of centimeters below the surface. 3. Offset magnetic field. Mercury's magnetic field is offset along the planetary spin axis by about 20% of the planet's radius. The internal magnetic field is 100 times weaker than that of Earth. The interaction of the planetary field with the solar wind generates currents in the magnetosphere, which induce external magnetic fields. 4. Hollows. Hollows are shallow, irregular depressions and are a geologic landform that appears to be unique to Mercury. Hollows are also some of the brightest and youngest features on Mercury's surface. The floor of the 32-kilometer diameter crater Curtiss shown here is extensively covered with hollows. The etched nature of the features suggests that material is being lost from the surface to create the hollows. 5. Volcanic deposits. Volcanism has played a critical role in shaping Mercury's surface. The scene begins with Timgad valleys near the top of the screen and Anchor valleys near the bottom. Both valleys formed by the mechanical and thermal erosion of Mercury's surface by hot, quickly flowing lavas. Next you can see the large crater Kofi, which is 136 kilometers diameter, which has been flooded with lava. The next part shows remarkable range in elemental abundances displayed by the volcanic deposits that make up Mercury's surface. Silicon is known to be relatively homogeneous across the surface, so these maps demonstrate variations in the abundances of magnesium and aluminum due to the surface volcanic deposits. 6. Global contraction. This image provides a perspective view of the central portion of Carnegie Rupees, a large tectonic landform that cuts through Duccio crater, which is 133 kilometers diameter. Red color indicates high-standing terrain, and blue indicates low-lying terrain. Tectonic landforms such as Carnegie Rupees was formed by horizontal shortening in response to cooling and contraction of the planetary interior. It is important to note that Mercury contracted by as much as 7 kilometers in radius. 7. Seasonal exosphere. Mercury's tenuous atmosphere scatters sunlight, and the brightness of the emission is proportional to its content. Scattered sunlight gives sodium a bright orange glow. Orange indicates high concentrations of sodium, and blue indicates low concentrations. During parts of a Mercury year, the radiation pressure from the scattering process is sufficiently strong to strip much of the atmosphere and form a long glowing tail. Someone standing on Mercury's night side at the right time of year would see a faint orange similar to a city sky illuminated by sodium streetlights. 8. Dynamic magnetosphere. Mercury's magnetosphere is highly dynamic because of the planet's small magnetic field and proximity to the Sun. The mixing of solar wind and magnetospheric plasma is just one of many processes that cause Mercury's magnetosphere to be highly dynamic. 9. Energetic electrons. A puzzle raised after brief observations by the Mariner 10 spacecraft was the nature of apparent bursts of energetic particles. The energetic particles are electrons, not ions, and they have energies from several thousands of electron volts to 100 times that energy. Electrons with energies in excess of 1000 electron volts can produce X-rays by hitting parts of the spacecraft or instruments. The electrons are seen at all local times and within a planetary diameter of the center of Mercury, although more tend to be located near dawn. These electrons are therefore almost a permanent feature of Mercury's magnetosphere. 10. Field-aligned currents. Magnetic field observations by the Messenger spacecraft in orbit about Mercury revealed flow of electric current from the magnetosphere to low altitudes along magnetic field lines. These field-aligned, or Brookland, currents flow downward, indicated by blue at dawn, and upward, indicated by red color at dusk, and have magnitudes 100 times smaller than at Earth. Messenger entered orbit around Mercury on March 18, 2011, becoming the first spacecraft to do so. Following 2 mission extensions, the spacecraft used the last of its maneuvering propellant to deorbit, impacting the surface of Mercury on April 30, 2015 at a speed of more than 3.91 kilometers per second, marking the end of operations for the hugely successful Mercury orbiter. If you have reached the end of this video, thanks for that. Do like, subscribe and place your comment for the video.